Welcome back, Year 10. This is exercise 8C, a little bit of a review, mostly, of probability that we did in the previous couple of years. So let's have a look. What are our learning intentions today? To understand and know the addition rule for finding the union of two events. So the union, something or something else, the one or the other. And we've got an example of it right here. There's set A as B, the other circle. A or B, you can see they've shaded in both circles there. Why is it that the rule says it's probability of A plus the probability of B and then minus the probability that they intersect? Well, let's have a think about what would happen. When I find the probability of A, I'm finding that area shaded in the first diagram there. When I'm finding the probability of B, that's equivalent to the area in the second diagram there. That middle bit, that intersecting bit, the A intersect B, that's been counted twice, hasn't it? Once in group A and also once in group B. So to get the actual probability, I need to take that probability of the intersection away once. Because I've counted it twice. So if I subtract it again, then I'll only have counted it once, and we'll be fine. One other definition for this exercise is pretty straightforward. If A and B are mutually exclusive, then the probability that they intersect is 0. You cannot be a member of both set A and set B at the same time. It could be something along the lines of, is a particular element a metal or not? Something is either a metal or it's not. There are lots of things. You can think of 1,000 examples of your own. In those cases, the probability of A or B is the probability of A plus the probability of B. It's actually still following the same rule. It's just that this probability of the intersection is 0. So really, it's just the one rule for this whole exercise. You're going to find it a little bit faster and a little bit easier, perhaps, than some of the trigonometry we've been doing. Let's have a quick look at a couple of examples. I'll work through these first ones. You can work through those other ones if you want to. And then you can get stuck in. Quick one today. So a card is selected from a standard deck of 52 playing cards. 4 suits, hearts, diamonds, clubs, spades, no jokers. Let A be the event that the card is a diamond and B be the event that it's a jack. So different ways, or the number of elements in that set. How many elements are there in set A? The card is a diamond. Well, 1/4 of 52 is 13, so there are going to be 13 diamonds. How many jacks are there? There are definitely 4 jacks, 1 in each suit. And how many are there in the intersection? Diamonds and jacks? You got it, there's 1 jack of diamonds. So the number in that group is 1. How do I go and find out these probabilities then? Well, 13 over 52, but you've already figured out all the suits are equally represented. I could just say the probability of being a diamond is 1 in 4. 1/4. What about the next one? Probability that I'm not in group A? Well, I could add up all the spades, the clubs, and the hearts, or I could just say it's 1 minus, leaning on just the perimeter of the computer sometimes annoys it. It's 1 minus the probability of A, which of course you've done in your head already. It's 3/4. I'm just taking time there, wasting valuable seconds of your life. Oh no. What about the probability that it's in set A and set B? We talked about that already. There's only one of those cards, so it would be 1 out of 52. Really straightforward stuff. Use the addition rule to find the probability of A or B. I'm going to write over here. It's going to work a little bit better for me, I think. Why did I write the or as a U? It is not a U. It is a little bracket like that. Sometimes my hand does things my brain doesn't want it to do. Probability of A or B. Use the addition rule to find that. So it's a probability of A. Now, I could write it as 1/4, but I'm going to keep it as 13 over 52, just because it's going to make my life a little bit easier. Plus the probability of B. Again, this is 1 out of 13, because there are 13 different cards in each suit. But I'm going to go for 4 out of 52, because there are 4 out of the 52. And then I'm going to subtract the 1 out of 52, that jack of diamonds that got counted once here in the diamonds and once here in the jacks. So all of the diamonds plus all of the jacks, I've counted that jack of diamonds twice, so I get rid of it once. So 17 minus 1, 16 over 52, and then I'm going to simplify. I think you'll just find it easier if you work out a 52 with these until your final answer. Of course, 4 goes into each of those, so we're going to end up with find the probability that the card is a jack or not a diamond. So not a diamond or a jack. Well, we can do the same. We can use the same method. The number that not diamonds, 52. The number of jacks is still 4 out of 52. Now we have to minus the number that are in the not diamonds and jacks. Well, there are 3 of those, aren't there? So, adding those together, 39 and 4 is 43, minus 3 is 40 out of 52. Which, when we divide by 4, we're going to get 10 out of 13. Alright, there's a couple there for you to try. I think you're going to be A-OK with this. The addition rule here, you can do it even if you don't know what the events are, if they give you the information. Probability of A and B, probability of A, 0.4, plus the probability of B, 0.8. What are we doing now? I better do it. I was going to just leave you to do it, but I can't help myself. Probability of A or B is the probability of A. Oh, I wish my stylus was behaving today. Plus the probability of B minus the probability of A and B. You fill in what you know, and you can go ahead and work out the answer, which is what I was in the middle of describing to you there. So I've got 0.85 equals 0.4 plus 0.8 minus the probability of A and B. Well, I'm going to add the probability of A and B to the other side because that's going to make my life easier. It'll be positive then, which means I want to get rid of that 0.85. So I'm going to do that first. Probability of A and B equals 0.4 plus 0.8 minus 0.85, which is, of course, 0.35. All right, now I'll let you go. Nearly 7 minutes. That'll do us. Catch you in the next one. Bye.